Hey everyone, welcome back. We're working on lesson 4. We're going to be looking at solving log equations. And there's essentially, two main types of solving log equations. We're going to skip this, but we're going to look at this exploration, which is more about the types of answers that you would get when you solve a log equation. So to begin with on this one, they just walk you through someone who had a log equation. Now, a log equation is one in which the variable is inside the logarithm, okay? Don't necessarily need to have two logarithms like this, but the variable is definitely inside the logarithm. And we have done some questions like that before where it's just been one logarithm and we've changed it to exponential form. Ultimately, that's our goal. So we now have two logarithms being added together on this particular example. So we have to think, okay, they're both base 5. We're adding, so we can use our product law from logarithms, where that's the same as multiplying within one log. So that would become log base 5 of x plus 1 times x minus 3. Okay, now we're going to get rid of the log because what we're trying to get at is inside the log. So to get rid of the log, we, bad grammar, exponent it, or raise the roof. It's been labeled as. Okay, so we would get rid of that by exponenting it, and here we go. We have that. All right, now we're going to continue on with the solution here. Essentially, well, 5 to the 1 is going to be 5, and our goal basically is to set it to 0 and factor it, but you know why? It's because we essentially have a quadratic equation now. So please don't be setting each one of these factors equal to 5, because that's not the principle. We want to be set up so it's a times b equals 0, so therefore a would equal 0 or b would equal 0. That's where we want to go with this quadratic equation. So we are going to have to expand first. I know, seems weird. So we're going to FOIL this out. Okay, so and we would end up with x squared minus 2x minus 3, and then on the right hand side we have 5. Okay, well that's looking good. Let's subtract the 5 over. So x squared minus 2x minus 8 now, because we want minus 5, minus 5. Okay, and now that it's equal to 0, which is what we needed, we're going to factor. Okay, so x times x gives us x squared, and multiplies to 8, negative 8 adds to negative 2, or has a difference of 2 really, would be minus 4 plus 2. Okay, now that it's nicely factored, we're going to branch each factor off to equal 0 using our zero product law over there. Okay, so x would equal 4 if we solve that equation, and x equals negative 2. All right, now to verify, it says explain what happens when you try to verify these ones in your original equation. So if we go log base 5 of, and if we put in 4, we'd have 4 plus 1, and then plus log base 5 of 4 minus 3 equals 1. So we'd have log base 5 of 5 plus log base 5 of 1. Okay, and we would get log base 5 of 5 is 1, because it's the exponent when the bases are the same. And log base 5 of 1 is actually 0, because that's the same as log base 5 of 5 to the 0. Okay, and look what we get, 1 equals 1. So that one's all good. Okay, let's try negative 2. So we would go log base 5 of 2 plus 1 plus negative 2 plus 1, log base 5 of negative 2 minus 3 equals 1. Okay, log base 5 of negative 1. Okay, now we can stop right there, because what's going on, remember back to your log graph, it looks kind of like this. Okay, along here, the x-axis, represents what really is inside of the log, right? So let's say we have something like log x, or even log base 5 of x. So if I was to put y equals log base 5 of negative 1, well, let's go to where x is negative 1, over here, right? Well, we're nowhere on the graph. So that really is why what's inside the log has to be greater than 0, because our graph doesn't exist left of that. So that means this one is not possible. And what that relates to back in the solutions here is this root here is extraneous, and this one is our only answer. Okay, so what I would expect is for you to kind of circle the real root and either indicate by crossing off, so I can still see it, but cross it off, or write extraneous. Okay, now just because the answer is negative doesn't mean when you sub it back in, you're still going to get a negative inside the log. Okay, so keep that in mind. All right, we are going to look at the next page actually. So this up here is really what I was just talking about with the negative answer, and you check back as long as you're not logging 0 or a negative number, then the answer works. Okay, let's look at example number 1 here. Solve the following logarithmic equations. We have log of x squared equals 16 and 2 log x equals log 16. Okay, let's go back to this one. So we have log of something equals log of something. So of course, therefore, x squared would equal 16, but you can get rid of the logs by doing exponent both sides as well, and that gets rid of the base 10 log that we had, right? No base was written there, so it was base 10. And then we would have x squared equals 16, square root of both sides, and we would have plus or minus 4. Okay, let's look at this one here. Looks very similar, doesn't it? Okay, can't really raise both sides to base 10 right at the moment because that 2 is in the way. So let's use our power rule and bring it back into the exponent so that we have log of x squared equals 16. Wow, that looks a lot like what we had over here. Okay, so forgot my log here. Equals log of 16. Then we get rid of the logs, both sides, and we have x squared equals 16, which again, x equals plus or minus 4. Okay. Now, we should always verify here. So when we sub 4 back in, it's fine here. However, when we sub negative 4 back in, you'll notice we would be logging a negative number. So really, negative 4 is extraneous. So we would only go with the positive 4. So x equals negative 4 is extraneous. Okay, so just x equals 4. What about over here? Here, if we sub negative 4 back in for x, we're squaring it first. So therefore, this one is good. Both of those answers are fine. Okay, now they want you to demonstrate what we just discovered with the graphing calculator. So what we're going to do for each of these is we're going to put the left-hand side in y1, log of x squared, and the right-hand side in y2. And then let's sketch our graphs on each of these two graphs and do the same thing for the other one. y1 equals 2 log x and y2 equals log 16. Okay, and then we'll take a look at the two graphs. All right, pause your video. Okay, so on our graphing calculator we ended up with these two different graphs, which really reinforces the idea that there were two answers for the first equation and only one for the second. And it says explain why the solutions to these log equations are not the same, even though on that second step in the second equation we were able to make it look exactly like the first equation. And it's got to do with how they started off. So when we subbed basically negative 4 back in on this first equation, we squared it, and so therefore none of our x values would be a problem because you're squaring them and then taking the log. So that's why we have basically x's now in the reals for the first graph. But for the second graph, because x is inside the log and we can't log a 0 or a negative, actually this is probably going more down like this. I shouldn't actually be touching the axes here. Come to think of it, and the graph didn't show that, did they? Anyways, so back to the point. So for this one, x is not being squared, and therefore we're restricted to just positive values for x. Okay? So let me just change those graphs, because if your calculator was like mine, this is how it showed up. But really, we can't equal 0 for the log, so the graph should be more like this. Okay. All right, let's take a look at the next page. Okay, so example number 2, we've got a couple equations that we're going to solve. So let's take a look at the first one here. So you'll notice x is inside the logarithm, so indeed we're going to have to get rid of the log at some point. And let's see, both base 4, that means we can use our logarithm laws, and we're subtracting. So if you recall, that's our quotient law, which states that if you're subtracting 2 separate logs, we could write that as dividing what's inside the log within one logarithm. Okay, so we change that. We're really using our skills from lessons 6 and 7 now and applying them to an equation. All right, so this looks good. Now, why did we want to do that? Because we cannot raise the roof. Do not do this, okay? This is an example of what not to do. Okay, we cannot raise the roof on all 3 of these and get rid of the log. Do not do that, okay? Because if you're raising the roof, how many hands do you have? 2. Not 3, not 3. Get rid of all these. Okay, so the reason why you have to have one term on either side, basically, before you can change it to exponential form. So here we go. Now we can do that. Log base 4, so we're getting rid of it by going 4 to the. And we have now x plus 1 over 2x minus 3 equals 8. Okay, now we just solve it like a regular equation. I'm going to move over here a bit so that I have the room. First, we need to get rid of this ugly fraction because it's bothering me. Okay, so we'll multiply both sides by 2x minus 3. Okay, and now we have x plus 1 equals 8 times 2x minus 3. So let's go ahead and multiply that 8 through. 16x minus 24. Alright, so now we want to get x on one side, so subtract x. That's really the first thing you should focus on, is getting x on one side, then worry about the numbers. So also we are going to, minus 24 there. We are going to add 24 to both sides to get rid of the number on the side with the 15x. Okay, so we now have 26 on the left-hand side. Okay, that's looking good. Now, just divide by 15. 26 over 15. And let's see, can we reduce that? No, 26 only has 1, 2, 13, and 26 as factors. Okay, so we're there. Now, with log equations, always, always, always check to make sure that this answer for x does not result in us logging a negative number. So 26 over 15, that's a little less than 2. So if we put a little less than 2 in here, still positive. A little less than 2, still positive. Okay, so that means this answer is good to go. We're fine with that. Okay, let's look at example B. All right, so we have log base 6 of x plus 4 equals 1 minus log base 6 of x plus 3. We have one term on the left side, 2 terms on the right-hand side. So we can't just get rid of the logs right now. All right, and it's not going to be easy to combine these two. We could in a difficult way by making one a log base 6, but there's an easier way. We have 2 log base 6s. Why don't we add log base 6 x plus 3 to both sides, and we can look at then combining them. So then we have log base 6 of x plus 4 plus log base 6 of, nice bracket of x plus 3 equals 1. All right, so we have a log plus a log. We can use our product law to combine those. So we would have log base 6 of, and now we're multiplying within that logarithm. Okay, now we can go ahead and expand what's inside, and we might as well get rid of the log at this time too. So we have log base 6 we want to get rid of, so we exponent both sides. That gets rid of that, and we use base 6 because that was the base on the log. So we would have then, expanding the inside, x squared plus 7x plus 12 equals 6. Good. Okay, why don't you guys finish that one up? Remember our zero product law. We don't want to try and factor the left-hand side until we have 0 on the right-hand side. So you know what to do. And once you get your 2 answers, check back and see which one is correct, okay? So pause your video, please. Okay, so how did that one go? Did you guys all get x equals -6 and x equals -1? Now, when you check back, though, -6 put back in here, -6 plus 4 would give you -2. Well, you can't log a negative number, so this one is extraneous, okay? But x equals -1, don't assume just because the answer is negative that you can't log that. So let's put -1 back in. We'd have -1 plus 4, that's 3, we're fine there. -1 plus 3, okay, that's equal to 2. and then we're fine there as well. So another way to look at that